So due to this reason, so previously also you have learnt in simple harmonic motion, you have learnt that the displacement in simple harmonic motion is a sinusoidal function of time. The same way, even the velocity, acceleration, they are also coming as sinusoidal functions of time. Exact, for example, in SHM, you have learned the equation for displacement as y is equal to a sine omega t. Here, this omega t is called as phase of SHM. Sometimes the phase is also written as omega t plus or minus phi, also it's written. So whatever angle that is considered inside sine, whether it's omega t or omega t plus or minus, it's called as phase of SHM. The same way here also, omega t is called as the phase of the current. So it can be seen that the phase of voltage and current are one and the same. The phases are one and the same. This is omega t here, the phase for voltage. Even current also phase is the same. On this phase only, the peak value or whenever, so on this phase only, for example, when omega t is 90 degrees, that is pi by 2, sine omega t is maximum 1, then voltage is also maximum, current also is maximum. So they are having the same phase at any given time, voltage and current. So the phase difference between voltage and current is said to be zero. This is very, very, very important result in case of a resistor. Only in case of a resistor this result will be coming. It will not be coming in case other components like capacitor and that is inductor, etc. Only in case of resistor we will be getting this result. Always current and voltage, they will be having the same phase at any given time, or the phase difference between current and voltage is said to be zero. These are very, very, very important results. Now this can be more clearly understood by drawing a graph. This graph already we have seen in the previous lesson, that is in the previous lesson derivation, the AC generator. Now that derivation is very, very useful even here also. Just check the derivation once. So I'll just use another page. So whatever things we are seeing here are simple, nowhere any complications there. Now try to remember the graph here, how the graph was actually drawn. So the graph was actually drawn by selecting an x-axis and a y-axis. Just see here. So this is the x-axis. So this is the origin, x-axis, and this is the y-axis. So EMF is taken on the y-axis, the positive y-axis, and this is the negative y-axis. EMF, or here the EMF E here is coming as what? Potential difference. And not only the EMF, even current also can be taken along the y-axis. And time is taken along the x-axis. Really, strictly speaking, when we have seen this particular graph, so just consider the equation. So I'm just using the, we'll just check the equation for EMF. EMF, we have seen that it is equal to E naught sine omega t in the AC current, alternating current generator. The same thing here, it has become what? V is equal to V naught sine omega. Only the terminology has changed. The representation has changed. We got it by exact proof. The EMF of the voltage source is coming to be exactly equal to the voltage or potential difference across the resistor. The peak EMF is becoming peak voltage. So slightly names have changed. We got everything, each and everything by proper proof we got. So that's the thing. So even current equation was what? I is equal to I naught sine omega. Exactly same result we got even here. This result we got using Ohm's law, and the same result we got using Kirchhoff's voltage law also. So both the equations we got, just try to remember. So just see here, this was the thing. I is equal to fourth result. So the same thing we are using here. So again, coming back to the present page. So here I said at the beginning of this topic also, omega t is nothing but the angle theta. What is the angle theta? The angle theta, just try to remember, theta here is the angle through which the coil is actually rotating from the initial position is taken to be parallel to the two faces of the coil. So the angle through which it rotates, that's denoted as in a given time t, is taken as theta. That theta is nothing but omega t. So again, using the same fact here, So omega t is theta. So that theta was actually taken along the x-axis. But theta is what omega t is. Theta and t are proportional. So not just theta, even time also can be taken along the x-axis. So here the time is important because we'll never be using the this quantity theta. Only in the AC generator theta was important, but here it is not important. Time is important. So now the important thing is, initially when time was 0, omega into 0 is 0, sine 0 is 0, so EMF is 0. So EMF is taken along the y-axis, time is taken along the x-axis. So time is 0, EMF is also 0. So this is the first pair. Time value is taken along the x-axis means time value is nothing like x value or x coordinate. So EMF values are taken along the y-axis. They are called as y coordinates or y values. So the very first pair of values of t and e. So as t changes, t is the independent variable like x variable. EMF E is the dependent variable or y variable. So xy pair of values initially is 0. T is 0, E is 0. So 0 0 means the point representing 0 0. X coordinate 0, y coordinate 0 is the origin. So this is the very first point representing 0 0. The very first point of drawing the graph is in the graph is the origin itself. Now as time increases, just observe here, as time increases, that means theta increases 0 onwards, sine 0 is 0, 0 increases 0, 10 degrees, 20 degrees, 30 degrees like that. As time increases, theta increases 10 degrees, 20 degrees like that. Sine theta also increases till theta becomes 90 degrees. So once theta becomes 90 degrees here, corresponding to some particular time where theta becomes 90 degrees, EMF goes on increasing like this and it will become reach maximum value like this. This way we got the graph. Then beyond 90 degrees, so this corresponds to what? Pi by 2. This corresponds to pi by 2. Theta is equal to pi by 2. This particular point. So EMF has become maximum. What is that maximum EMF here? E naught. It is also nothing but V naught, the peak voltage. EMF has become maximum. Even current also will be getting, because sine theta is becoming maximum, current also becomes maximum. So this point represents maximum EMF or maximum voltage or even maximum current also. Same graph will be getting for current also. That already we have seen. The same thing we are seeing even here also. Now when theta becomes beyond pi by 2, that is beyond pi by 2 means 90 degrees. More than 90 degrees means 100, 110, 120. Then sine theta starts decreasing. Sine theta is maximum only at 90 degrees. But when 90 degrees, above 90 degrees values are reached, sine theta decreases, starts decreasing again. So then EMF also decreases because it's proportional to sine theta. So the graph goes down like this. And finally at 180 degrees, that means theta is equal to 180 degrees. 180 degrees means pi. So theta is equal to pi. Then graph will be, so EMF again becomes 0. 0 means it touches the x-axis. Only at the x-axis, the y coordinate values, EMF values will be 0. That's how we got the, so up to pi. So next what happens? More than pi means what? 180 degrees. More than 180 degrees. Up to 0 to 180 degrees, sine theta will be positive. But beyond 180 degrees, sine theta will become negative. So once sine theta becomes negative, EMF becomes negative. But from 0 values, so beyond, that is from 180 degrees, above 180 degrees, at 180 degrees, EMF has become 0. But beyond 180 degrees, EMF becomes negative. But negative value starts increasing. Ignore the negative value, but negative values means the graph will be below the x-axis. Positive values of EMF means graph was above the x-axis. Negative values of EMF means graph will be below the x-axis. The higher the EMF, the graph will be at more distance from the x-axis. Just see here, maximum distance means maximum EMF from the x-axis. Now just see here. So whatever things we are seeing here are simple. So nowhere any complication is there. So now what is happening is beyond 180 degrees, what happens is the EMF sine theta becomes negative, sine values becomes negative. So EMF, just observe the cursor compulsorily, EMF becomes negative. So graph goes below the x-axis. But as theta increases beyond 180 degrees, so just like sine 180 degrees 0, here sine 0, theta is 0 means sine 0 is 0. So beyond 0, EMF is increasing 0 to 180 degrees, 0 to 90 degrees. The same way from 180 degrees to still higher values, what happens is negative values gradually increase. That means the graph will become again more and more away from the x-axis, but down below the x-axis it will be present. So this way. And finally at beyond, once the angle reaches pi means 180 degrees. Just remember, see the cursor, pi is 180 degrees. So once the angle increases by another 90 degrees, what happens? 180 plus 90 is 270. This is written as 3 pi by 2. So 3 pi by 2. What happens is the EMF again becomes maximum. The EMF will be again becoming maximum. At this stage, 3 pi by 2. Sine 3 pi by 2 is minus 1. So the EMF will be minus E naught. So here again peak value of EMF is reached, which is nothing but what? Minus E naught. Minus E naught means the voltage will be how much? Minus V naught. The peak voltage reached is minus V naught. This will be happening at 3 pi by 2 at one particular time. And beyond this, as theta further increases, that means as time further increases beyond 270 degrees, then the EMF starts decreasing. So after reaching the maximum value, what is happening? The EMF decreases. In the positive values also we have seen. The same thing you will be repeating here in the negative values also. Beyond 270 degrees, the EMF starts decreasing. In the negative value starting, that means the graph becomes again closer and closer, goes closer and closer to the x-axis. This will continue till finally when the angle increases by another 90 degrees. So this is 3 pi by 2 plus pi by 2 is what? 4 pi by 2 is nothing but 2 pi. 2 pi radians. So this way the graph will be finally here 2 pi radians means the 2 pi sine 2 pi is what? Sine 2 pi means 2 into pi is 180 degrees. 2 into 180 degrees is 360 degrees. Sine 360 degrees is again 0. So the graph will be again sine 360 is 0 means sine theta is becoming 0. So E naught into 0 is 0. So the EMF again becomes 0. That means the graph will be again touching the x-axis. From the negative values is touching the x-axis. This way what is happening is once theta increases from 0 to, just see here, 0 to 2 pi or 0 to 360 degrees, the EMF is taking different values. Initially positive values, then later negative values it is taking. So theta is 360 degrees means the angle theta is already we have seen that is the angle of rotation. Just look at the diagram once again, the basic diagram. So when the coil has rotated through 360 degrees, the 360 degrees is nothing but one full rotation. The EMF takes on different values. Initially for the first half time interval it takes positive values, next half time interval or next half rotation it takes negative values. Just look at that once again here, it can be understood more clearly here. So first half of the angle of rotation, that means up to 0 to pi radians, that means 0 to 180 degrees. Pi radians means 180 degrees. EMF is completely positive, and in the next half of the increase of angle from 180 degrees to 360 degrees, that's the next half of the rotation. Actually this half rotation from 0 to 180 degrees it has rotated, and then 180 degrees to 360 degrees another half rotation. The EMF throughout this next second half of the rotation, EMF is completely negative. EMF is negative means even current also is negative. That means it actually represents the opposite direction of current. So all these things actually previously we have seen this in the alternating current generator. Even here also we can just see the same thing. Any doubt is there, you just check the alternating current generator, or even here also you can just think of it. But alternating current generator will be actually more giving more amount of understanding because it actually represents each and every step of the very important laws, and the use of the trigonometric equations also we have seen in the alternating current generator. So that gives actually more clearer understanding compared to this one. But still this is also not bad, this is also sufficient for understanding basic things or the main things here about the graph. Now just see here, when one full rotation is completed, the time taken is called as time period. So the time taken here is nothing but time period equal to time period. So just first half of the rotation, time taken is t by 2. So this actually represents t by 2. So what about this now? This is 1/4 of the rotation. So time taken will be 1/4 of the time period. That means t by 4 here. This actually, if we're taking time values on the x-axis, theta values on the x-axis means this is the values pi by 2, pi, 3 pi by 2, 2 pi, as we have seen in the AC generator. But now here theta values are actually not considered. Only for the sake of understanding we have considered them here. But here the important things is time. Now this is t by 2 half rotation. This is full rotation of the coil. Time taken is time period. Now this is 3/4. 3/4 means 3 by 4 t. So this is how it's actually represented. This is called as one full cycle. One full rotation is called as one cycle. First half of the cycle is called positive half cycle, and second half of the cycle is called as negative half cycle. So in the positive half cycle, current flows in one direction, say clockwise. The negative half cycle, the current flows in the anti-clockwise direction. So that's the importance of this graph. So now what about the graph? So this is actually really the graph for EMF and time. What about current and time? Current and time also the same graph will be coming because the equation is similar. This particular graph is actually really called as sine curve. The reason is if we take a, if we not just E is equal to E naught sine omega t, even if we take a y values, I'll just call it as y is equal to sine theta. If you really draw a graph between theta and sine theta, y is equal to sine theta means between theta, sine theta values are taken on the y axis, then also we'll get the same graph. That's why it's called as sine curve. So any equation which is proportional to sine theta, whether it's EMF or current or even just plain sine theta, the graph always will be coming like this. That's why it's called as, so that's why EMF is said to be, graph is said to be a sine curve, even current is also said to be a sine curve. But exactly speaking here, if we really draw the equation for current over the, that is if we really draw the graph for current over the graph for EMF, both will be slightly different. The reason is, just see here equation. Now just see the equation here. I is equal to I naught sine omega t. What is I naught? We have seen that I naught obeys Ohm's law. It is nothing but peak EMF, E naught divided by resistance. So the equation becomes like this. Now assuming that resistance is greater than 1 ohm, assume that resistance is greater than 1 ohm. EMF is say 10 volts. 10 by, it is equal to 1 means 10 by 1 is 10 only. So peak current also is 10 amperes. It will be coming 10 by 1 is 10 amperes. But if it is greater than 1 ohm, then 10 by greater than 1 means 2, 3 like that. 10 by 2, 10 by 3, they are clearly less than 10. So the peak current value will be slightly, if resistance is happens to be greater than 1 ohm, the peak current will be lesser. So if we really draw a graph between current and time, for resistance greater than 1, the peak current value will be coming slightly below the peak EMF. So this is how the graph will be coming for current and time. So this will be what? Peak current, I naught. For resistance, if we assume that resistance is greater than 1 ohm, usually resistance will be very high, 10 ohms, 20 ohms like that. If resistance happens to be less than 1 ohm, then current will be actually higher. So less than 1 ohm means like half. Then peak current will be what? You put in place of R, observe the cursor compulsorily, in place of R you put half. Less than 1 ohm. 1 ohm if resistance happens to be. Half if you put 2 E naught. That means peak current will be twice the, numerically it's twice the peak EMF. So current, peak current value will be higher than, numerically higher than the peak EMF. Numerically I am saying, because the two quantities can't be compared, they are different. Current and EMF are different. They can never be compared. Two currents can be compared, but we can't say that current is greater than EMF because they are different quantities. Numerically I am saying. So graph will be coming higher. But now we are taking a simple case when the resistance happens to be greater than 1 ohm. So peak current numerically it will be lesser than the numerical value of EMF. So the graph for, so even negative also will be lesser. Somewhere here it will be coming. So this will be what? Minus I naught. This way it will be coming. So this is the EMF graph. E is equal to E naught sine omega t, or V is equal to V naught sine omega t. And this is for what? The current. I is equal to I naught sine omega t. This is about this. So these are the things related to the. Now most important result is when EMF is becoming maximum at some particular time, current also is maximum. When EMF is become minimum, current also is minimum. So they are said to have the same phase. The phase difference is said to be 0. Whenever two quantities which are sinusoidal functions, the phase difference is 0. Phase difference. Now phase here, just see here, this is a phase omega t, the phase of the current. So phase of one quantity is denoted as say theta 1. So usually phase is also denoted as phi 1 also, and phase of another quantity is denoted as phi 2. The difference of the phase is denoted as phi 1 minus phi 2. This is called as phase difference. Whenever two quantities which are sinusoidal functions of time, the phase difference happens to be 0, 2 pi. 4 pi, 8 pi, that is multiples, integral multiples of 2 pi, including 0. 0 into 2 pi is 0. Not just when the phase difference is 0, even if the phase difference is 2 pi radians or 4 pi radians, or in general 2n into 2 pi, that's called 2n pi radians. In all such cases, they are said to be in phase. They are said to be in phase. The two quantities are said to be in phase. So the important thing here is current and voltage in case of a resistor are, so this is very very simple, very very important. The current and voltage in case of a resistor, just a moment please. For a resistor, the current and voltage, so whatever things we are seeing here are simple, so nowhere any complication is there. Whenever the, because the current and voltage, the phase difference is 0, they are said to be in phase. Not just 0, even if it's 2 pi also, 4 pi, 8 pi in all, or 2n pi, two quantities are said to be in phase. So here current and voltage in case of a resistor are said to be in phase, or we can also say that their phases are same, or we can also say that the phase difference is 0. So these are the various things related to the phases of current and resistance. They are very 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 useful to understand alternating current circuits. So these are some new terms that we have seen in this particular topic. So now the important thing is how to complete the running node.